Welcome to Stephanie's Academic Tuition Center. Yeah, so today I want us to do topic one. Topic one is physics. This is physics, in fact. Physics, science. Yeah, so this is physics, topic one. So I know some those people they don't understand English, so I'll be mixing English and vernacular so that everyone can able to get the concept. Yeah, so the first topic here, topic one, is measurements. So measurement. So this is a very important topic in physics. In fact, even in chemistry, you can also find this topic, and it's a very important topic. And for you to understand physics or science, you need to have knowledge on the same topic called measurement. So I'll start with the first part, which is a quantity. So talk about quantity. So I think that physics is the study of matter, energy, and their interaction. So it's very important to understand because we just say physics. Example, like I'm doing physics, I'm studying physics, so you can be caught unaware. Someone can able to ask you maybe what is physics. So it's very important to understand or to know the meaning of the subject, so which is physics. So in this case, we're saying that physics is the study of matter. So talk about this matter. So matter is anything that occupies space and it has got mass or weight. So matter is any substance that occupies space and it has got weight and mass. So physics is the study of matter, energy, and their interaction. So in short, we're saying that matter is any substance that occupies space and has got mass. So physics is the study of matter, energy, and their interaction. So when they ask you maybe at what is physics, so you can able to respond that physics is the study of matter, energy, and their interaction. Then the same physics, it deals with the physical quantities and motions of matter. So talk about the word motion. Motion means movement. So physics can deal with the the, the physical quantities and also the motions, which is the movement of matter. Yeah. Then apart from that, you can also further say we talk about physical quantity, physical, which means the physical means something that you can able to see, to touch, and feel. So, the physical quantity is a quantity that can be measured. So anything that can be measured, we call it a physical quantity. And this point is very important here. So physical quantity is a quantity that can be measured. It is expressed by a magnitude with a suitable unit. So magnitude here means the size. So this way is same as size. So size is same as magnitude. So if you want, you can say physical quantity is a quantity that can be measured. It is expressed by a size with a suitable unit. Hope it's very clear. So magnitude here, magnitude is the size of a quantity. So which means the size of the quantity we call it magnitude. For example, like 2, 150, 3, and 10 is size. So size is same as the magnitude. So if you want to say the size of this object, you can say the magnitude of this object, which is just same. So size and magnitude is just same. So unit, example, this is a unit of the unit. A unit is a standard. So unit is a standard measure of a quantity. For example, the unit for time is seconds. For then the meters also have meters, of kg, also have kilogram, which is same as the kg. So these are example of units. So units is the standard measure of quantity. So the standard measurement for time is seconds. For distance is meters. For kg, for mass is kilograms. So So example of units, we have seconds, meters, and kilogram, which is same as kg. Good. Then we go to the types of physical quantities. Since we said that the physical quantity is a quantity that can be measured. So example of quantity that can be measured, the quantity, the number one, the first one is the base quantity. So the base means the basic of something, the foundation of something. We call it the base quantity. So the base quantity, these are fundamental physical quantities. So these are quantities. These quantities, in fact, contains only one unit. So in short, the base quantity, they contain only one unit. So the base quantities, they contain only one unit. So any quantity that contain one unit, they are called base quantities. So there are 7 base quantities that you're supposed to know as a student. Number one is length, meters, temperature, time, current, amount of substance, and luminous intensity. So these are the base quantities. Sometimes they can ask you which of the following is a base quantity. So you're supposed to able to identify these 7 base quantities of length, mass, temperature, time, current, amount of substance, and luminous intensity. These are very, very, very good examples of base quantities. So don't forget, very important, the base quantities, there are 7, which are length, mass, temperature, time, current, amount of substance, and luminous intensity. So these are basic quantity, and they contain only one SI unit, or 1 unit. So number 2, apart from basic quantity, since I said that 2 types of physical quantities, number 2 is the derived quantity. So derived quantity, in short, in simple term, these they consist of 2 base quantities. Base, I said they contain only one. So when you combine the base plus another base, or base plus base plus base, when you combine 2 or more base quantities, they make what we call the derived quantity. Don't forget to take note. Base quantities, they contain only 1 unit. So when you get the same unit plus another unit, when you get 2 or more units, which is the base quantity, they form or they make what you call the derived quantity. For instance, we're saying that the derived quantities are quantities that consist of 2 or more base quantities. Therefore, they have a combination of units. So when that's what is the derived quantity, so derived quantity, they are combination of units. For example, we have speed is a derived quantity. Speed is the total distance covered per unit time. So that's what is speed. So speed, we say speed is equal to distance over time, which means speed is distance covered over time. So you need to know that the same speed is equal to distance. The unit for distance is meter, so you write meters here. Then per means time, which is second. So as you can see, the speed will be equal to meters per second. So meter is a base quantity and speed is a base quantity. So we try to combine these two. As you can see, we have meters per second. So I have two base quantities, and they become derived. So these are so in short, speed is a derived quantity because it contains 2 base quantities. Because as you can see, there is meter and second. So it's a combination of of base quantity. So it means a very good example of derived quantity is speed, because it's a combination of meter and second, which are the base quantities. Then the table below shows the base and the derived quantities. So as you can see from my table here, hope it's clear. The type of physical quantity, example, the base quantity and derived quantities. So the example of base quantities, as I said, as I have explained there, we have length, time, mass, temperature, current, amount of substance, and luminous intensity. Then now here, the derived quantities. So volume. This one is a combination of what? Example, you say meter times meter times meter, which is equal to what? Which is equal to meter to the power 3. So as you can see, volume is measured in what? In cubic. So as you can see, we have meter to the power 3, which is a meter cubic, which means a combination of what? Of meters. A meter alone here is a base quantity, but when you combine them, when you multiply meter times meter, you have meter cubic, which is the volume. So volume is a combination of meter, which is a combination of the base quantities. So the volume is the derived quantity. We also have density. So density is a gram per centimeter cubic, or density is kg per meter cubic. So as you can see, density is gram per centimeter cubic, which means a kg here is a base and meter here is a base. So it means when you combine kg and meter, 3 meters there, which means we have what we call, we have the derived quantity. So density is part of the derived quantity. Then speed, as I mentioned, as I have already explained there. So speed is also part of the derived quantity, the area, the force, and pressure. So these are examples of derived quantity. So it's, very careful. Especially in paper 1, they can ask you maybe, for example, like which of the following is a derived quantity. So they can get length, time, mass. Then they also get one from this point. So you're supposed to know the examples of derived quantity and the base quantities. So don't forget, these are very important. Good. So we'll talk about unit. As I have already explained under unit, I said that unit is the standard measure of quantity. Then now the SI, so SI unit, this one is an international agreed upon unit to be used worldwide. So SI unit is the international agreed upon unit to be used. So the international, they agreed on the following units to be used in the world. So SI unit, which is international system of the unit, are used as a standardized unit of measurement. So they are agreed worldwide to be using the following as the SI unit. And there are 7 units. So which is, for example, we have length. The unit for length is meters. Symbol is M. The unit for mass, the unit for mass is a kilogram, which is kg. The unit for temperature is Kelvin, and the symbol is K. For current is ampere, which is A. Amount of substance is mole, which is mole. Luminous intensity of candela, which is CD. So these are the SI unit used internationally. So as a student, you're supposed to understand or to know these SI units. Then I go to the next part, which is the scalar, and vector quantity. The scalar and the vector quantity. So scalar and vector quantities. So talk about a scalar quantity. I'll give a practical example. When someone tells you that Mr. Stephen is a scalar quantity, which means you don't have direction. So a scalar quantity is a quantity that only has magnitude, which is the size, but no direction. So which means a scalar quantity is a quantity which has got size, but no direction. So if someone tells you that my dear, you're a scalar quantity, which means you don't have direction. So a scalar quantity are indicated only by size of the quantity, but without direction. So examples of scalar quantities are example of length, we have time, we have mass, we have volume, we have density, we have distance, speed, area, pressure, weight, and temperature. These are examples of scalar quantities, which is the quantity with direction. Quantity with size, but without direction. So we need to understand and know the examples of scalar quantities. Then vector quantities. So these are quantities which have got both size and direction. So a vector quantity is a quantity that has both magnitude and direction. A vector quantities are indicated by size and also the direction of a motion of the quantity. Examples of vector quantities are, so it means the quantity with both size and direction. So we have displacement, we have velocity, we have acceleration, we have weight, we have gravity, and force. So here you need to be very careful. Sometimes they can bring a question and ask you, for example, they can say which of the following is not a vector quantity. So they can say displacement, velocity, acceleration. Then they can also get one from here, length. So automatically the answer will be length because length is a scalar quantity. Yeah. So now adding vector quantities. So when adding vector quantities, consider both the magnitude and direction. So when adding vector quantities, it means we need to know the direction and also the size, which is the magnitude of a motion of the quantity. So if both quantities are moving in the same direction, so if something is moving in the same direction, which means we add. But if they're moving in different direction, we need to subtract. For example, I'll draw a diagram here. For example, this is an object here, if this force going this direction and this force different direction, example of 4 Newton here and 8 Newton here. So as you can see, the forces here are going in different direction, which means we need to subtract. We say 8 minus 4. So be very careful here. And if the force says are moving in the same direction like this, 4 here, 8 here, Newton, which means we need to add this plus this. So we need to check, we need to look for the direction and the size of the force. So if the forces are in the same direction, so you add this plus this. So where V is the resultant force of vector, V1 and V2 are individual vector moving in the same direction. Then if they are moving in the different direction, so you need to subtract. For example, like V1 minus V2. So in short, if the forces are moving in the same direction, you add. And the forces are moving in this different direction, you need to subtract. Example. I've got examples here. Examples here. Find the resultant vector of the following forces. So as you can see, the 1 Newton is going to the right side and also 3 Newton going to the right side, which means the forces here are going in the same direction, which means we need to add. So we're going to add. So resultant vector R here is equal to, so we're going to add, so it is 3 plus 1. So the answer will be, so we're going to do like this. the answer will be, I'm going to say 1 plus 3. The answer will be 4 Newton, 4 Newton to the right. So the answer will be 4 Newton to the right. So the answer is 4 Newton here. The number 2, so you need to subtract the one which is going to this side. So resultant force again is equal to, so you start with this one going to the right, then minus the one opposing one, which is 3 Newton. So subtract here, so you subtract, force is equal to 1 minus 3 to be negative 2 Newton. So this will be our answer. So you need to subtract the one which is going this side minus the one coming backward, which is on the left hand side. So then number 3 question. So as you can see, we have two forces going this side. So say resultant force again is equal to, we're going to add, since these two forces are going in the same direction. So I'm going to say 3 plus 1 bracket, then now minus the 3 Newton going in the different direction. So the answer will be, so we say 4 Newton here minus 3. So the answer is 1 Newton. That this will be our final answer. So don't forget, when forces are going in the same direction, you add. Then if forces are going in different directions, subtract. So this is how I'm supposed to do it. So as you can see, the answers are here. You can try to confirm. Yeah, so this is topic 1. Thank you very much for watching. More videos will be posted. The next topic is under time calculation and etc. Thank you very much. May God bless you.